This is MAP4C, day 12, lesson 2.2 on volume and surface area. Last day we were just calculating volume and surface area of regular shapes, and today it's going to be composite objects, so objects that have been sort of put together, and we'll have to break them into their routine shapes. The 3-minute review is straight from yesterday's homework. Find the volume and surface area of this shape, and you can look up your formulas, but I'm just going to get going right away. The radius is 8, the height's 15. Bash that into a calculator, just like that. Pi times 8 squared times 15, and you get about 3015.9 centimeters cubed. And then the surface area, slightly more difficult formula. The 2 circles plus the curved part, and the radius and height are same as in the volume. That can go into your calculator in one step as well, and you should get, if you put that in carefully, and as long as I didn't make a mistake, 1156.1 centimeters squared. Okay, and today it's a review topic as well, but we're going to see that the questions that at least we do in class or together in the lesson are a little more complicated. This one, it's a porcelain sink, and it's 1 inch thick. You see, it kind of looks like this. It's been estimated here. Half cylinder with a triangular piece right there. Removed. How much porcelain's required? Well, how much porcelain's required? How much porcelain would fill this sort of half cylinder? That's a volume question, right? So that's a volume question. And this is going to actually take some planning, some thought to figure out how to calculate this volume, because this is a complicated shape. Composite figures means, you know, not straightforward, not the easiest one. Well, we can see that there's the outside cylinder, which the dimensions are given, and then the inside cylinder has kind of been carved out, subtracted. And so we're going to take the big cylinder and subtract the small cylinder that's inside. But notice, we don't need the entire cylinder, right? It's not like the sink is a drum, an oil drum or something like that. It's a half. So we're going to take the big, subtract small, and then divide by 2. So we'll get half the cylinder, and it'll be open in the middle. And then, of course, even after that, we've got to subtract off the triangular piece here, the triangular prism neck piece. So that's the plan. Now we'll put the pieces together here. So the big cylinder, it is just a cylinder. The radius, well, it gives us the diameter, so we got to go 18 divided by 2. That's 9 inches. The height is given in feet. Hopefully that's not throwing too many people for a loop. Got to change that to inches. 24 inches, and now we can bash that into a calculator. 9 squared times 24. And you get about a big number. That's a lot of cubic inches of porcelain. Oops. Cub in cubic inches. But that's if that's the whole thing and it's filled in, right? So we got to figure out the small, the inside part that's been carved out. It's still just a cylinder. But notice, how do we figure out the dimensions? Well, notice the radius here was 9 inches, but that included the 1 inch there. So if we take 1 inch off of the radius from the big one, we'll get the radius for the inside one, 8 inches. And the height, it was 24 for the entire thing, but there's an inch off of each end. So take an inch off of each end, 22 inches. And that's the volume of the inside one. Use your pi button. Pi times 8 squared times 12, or times 22 rather. And that's cub in as well. Okay, so we're going to subtract those two numbers and divide by 2, but then that'll give us the sink shape, but then we've got to subtract off the triangular part. And so the triangular part, I'm going to calculate wherever I can find a room for it. Triangular part, I'm just going to show what the face of it is here. You know, this part is that face. It says it's 8 inches wide and 4 inches deep, right? And then it's an inch thick this way. And that's kind of hard to draw, so I'm going to pretend that I can draw. But it's a triangular prism, isn't it? Which is area of the base times the height, no divided by, just area of the base times the height, because it's a prism. But the base is a triangle. And luckily, we don't have to use Pythagorean theorem or anything like that. We can just base times height divided by 2. The base is 8. The height is 4 divided by 2. That's 32 divided by 2 is 16. Now the height of the shape itself, well, that's just that 1 inch that it's thick, right? The sink is 1 inch thick. So the height of the prism, not the height of the triangle, but the height of the prism is just 1. We got 16 cub in cubic inches. And then overall, then what do we want? Well, we've got the big number, subtract the small number, the inside cylinder. I'm going to take that answer and divide it by 2. You could write it this way if you wanted to. And then I'm going to subtract off the 16. And you bash that into a calculator, you're going to get 841.95. Subtract 16, which is about 825.95 cubic inches of porcelain. And that sounds like a lot. Maybe it is. I don't know. I've never made a porcelain sink before. Number 2. How much corrugated aluminum will it take to construct this silo? Of course, sort of in the background here is us having to make the decision, is this a volume question or is this a surface area question? And the last one, filling a mold with porcelain to make a sink, that's volume. Here, this isn't filled with corrugated aluminum, it's just along the outside, right? And so, in fact, this is surface area. Surface area. But what is it? Notice that we think of it as a cylinder and a half sphere here, but there's no roof on this. This has got to hold grain or whatever, and it's going to go up to the top. It's not like it's going to run into a roof here, nor do most silos have floors. So really, we just have the half sphere on the top, and then the curved part of the cylinder, right? And so we don't have to add all the little bits and pieces. This is actually easier. Now you got to look up the surface area of a sphere, but its surface area for a sphere is 4 pi r squared, and then I'm going to divide it by 2 because it's only a half sphere. The radius is 10, and I can fire that into a calculator. That part is, bash that into a calculator, 628.3 square feet of aluminum. But then the curved part, The surface area of a cylinder, remember, is 2 pi r squared plus 2 pi rh. But the two circles we don't need. So we don't need this part of the surface area formula at all. It's just the 2 pi rh. And so we can sort of have a little bit of a shortcut there. 2 times pi times the radius is 10, the height's 16. Into a calculator we go again, and we get about 1,005.3 square feet. And then total, add them up. Sometimes in these questions in the homework you'll see there's some cost involved, but you know, we didn't have an example like that here because I think you're smart enough to handle those on your own when they come up. And these sorts of questions show up in all sorts of different jobs. So this is construction, I suppose. The last one would be, well, it would be construction as well, but I suppose someone in a salon would be worried about making sinks and big enough and all that business. So there you go. Surface area and volume of composite objects.